Invert binary 3, given the root of a binary 3, invert the 3, return its root. So this is our root for, so 2 and 7 were switched here, you know, and also the children nodes of the 7 and the 2 were also switched. So one over here was also switched. This and also this one, it's simpler and same concept. In this case, we don't have anything, so we don't get any, we don't have an input, so we won't get anything else. So let's make this case. Let's take care of that case first. So if nothing, if load is none, nothing, return nothing. Yeah. So if root is none, return none. And so now let's switch nodes. Okay, how will we do that? Let's make root dot left equals to root. It doesn't matter which order you do it in. Right. On the left side, it has to be consistent on the other side too. Uh, Let me put a comment here. Swap nodes of the children. Swap the children nodes of the node. So these two are the children node of the node. So since we have left over here, let's make root dot right equals to nope root dot left. So now let's make a recursive case. To invert the subvaries of the left and right. Okay, the left and right. So now let's make a self dot. I'll copy and paste this to make sure that there's no spelling mistake. That invert that right, nope, root dot right. So I'll copy and paste this too, and return our load. Our inverted load. And so this will make sure that every loop root keeps going on from this. So this is basically this over and over again until all of it is inverted in our binary tree. Oops, left. So we have right here and left here. And that's it. It does pass all cases. And now let's submit it. And that's it for this one. This one is an easy one. Binary tree.